Module 2, Equipment, covers the following topics: vertical vessel, horizontal vessel, pumps, and miscellaneous equipment. Our first topic in Module 2 is vertical vessels. Let's place a vertical vessel in our design. First, on our toolbox, we'll select the equipment module. We'll set our spec to none spec, as most equipment isn't based on the ANSI B31.3 spec. So now we have access to all of our icons. Select the shell cylinder. For the reference point, we can pick a random point on the screen or an absolute coordinate, and we'll just use 0, 0, 0 for a start point. For the distance, this is going to be the length of the shell of the vertical vessel. If we were to draw it out horizontally like this, it would be a horizontal vessel. Vertically creates a vertical shell. Put in a distance of, say, 14 feet. A shell cylinder dialog box appears, allowing us to change and set the outside diameter and the inside diameter. For the outside diameter, let's use 4 feet or 48 inches. Inside diameter, we'll use 44 inches, which will give us a 2-inch wall thickness for our vertical vessel. And on our option line, we can change the base point or just hit the Enter key to accept. And there is our shell cylinder. We can shade it just to give you an idea of what it looks like shaded, and you can actually see the thickness. We'll go back to wireframe. Next step is to add the heads. So you'll see various heads available in the toolbox. We'll select the 2:1 semi-elliptical head and a flange portion. On the screen, you will see connection cones, purple connection cones. These are the only locations that we can select that will automatically attach the head to the cylinder. Simply select the cone. It gives us the value for the flange thickness as well as the straight flange distance. Just click OK to accept, and our head is placed. Repeat the command for the bottom head, and you'll see now just the cone at the bottom is available as the one at the top was already used. Select the cone and select OK, and there is our vessel. So using our view toolbar, we can take a look from the top, from the front. We can shade it just to give you an idea of what it looks like shaded, and then we can go back to an isometric. When placing components, it's usually best to set it back to wireframe. As you can see, the internals. So let's add the skirt to the vessel. We have two skirts. We have a flared skirt or a straight skirt. We'll pick the straight skirt. We'll pick the bottom head to attach our skirt, and again a dialog box comes up. So on this one, the base thickness, we can leave it 4 inches. Overall height, we'll say is 6 feet, so 72 inches, and then the base diameter, and we'll use 60 inches or 5 feet. Click OK, and the skirt is added. Again, we can shade it quickly just to show what it would look like. And there is our vessel. Probably a good time to save our drawing. Just click Save, and now we can add some nozzles to our vessel. We can select flat-faced, raised-faced, or ring-type joint. We'll select raised-faced. Select the tool. Now it's asking to select the vessel shell. So we can pick the shell, and it actually orientates to the very bottom of the shell because I picked this end. And now we can give it a reference point from that bottom, and we can come up and give it a distance. So we'll say 8 feet. We'll come up from there. It then asks us which nozzle we'd like to place, and because we're set at none spec, it's going to show all the available types of nozzles. So we'll pick a 150-pound 6-inch nozzle. The dialog box appears showing default information about the nozzle. For now, we'll just take the defaults, and then it asks which location we want the nozzle at. And we'll just come off at the east and pick OK. Again, we can take a look at our top, our front view, and then again back to our isometric. Let's place another nozzle. This time we'll take it off the head of the vessel. We'll come off the top. Again, 150-pound, 4-inch. Again, a dialog box appears, allowing us to make some changes to the external projections to match equipment data sheets. And we can change any other information. On the top, we do have an offset. So if we want to make it a tangential connection, we can offset from the center of the vessel head a certain distance away. We'll just leave it at 0 and click OK. And the nozzle is placed. we can show you how to place one off the skirt for, say, a liquid outlet or a drain connection. We'll go in and pick our raised face nozzle. This time we'll pick the skirt. And then again, it references from the top of the skirt. So we need to reference down. So we just pull straight down, go 4 feet. Pick our nozzle. And again, we'll select the 4-inch. Ask for any changes. We could just say OK. And then we can pick our direction. If you need a different angle under the options down at the bottom here, we can select O for options. And then we can rotate. So if we wanted to rotate at 45 degrees, we can say R for rotate and say 45. And we'll rotate at 45. Rotate, we can say -90, and it brings it back 90 degrees. Or we can just rotate it to the exact south. Any angle is available. 30 degrees, 60 degrees, whatever we need. Click Enter to accept, and the nozzle is placed. We can shade our model, and then we can see the nozzle off the top, off the side, and then off the bottom. Again, a good time to save the drawing. Our next topic is horizontal vessels. On our drawing, we have completed our vertical vessel. We'll just pan over, and let's draw a horizontal vessel. Similar sequence, we'll pick our shell cylinder. For a reference point, I'll just pick a random point on the screen this time. Then I'll drag off, instead of in the vertical direction for a vertical shell, we'll drag off in the horizontal, and we'll put in a distance of 18 feet. The dialog box appears to allow us to change the outside and inside diameters. This time we'll use an 8-foot, 96-inch, 90 for the inside diameter, giving us a 3-inch thick wall thickness, and click OK. Enter to accept. Again, we'll go back to wireframe, make it a little easier to see our connection cones when we put our heads in. And with this one, let's try some hemispherical heads. Pick the tool. Again, we get the cones. Pick the cone. Values show up. So it automatically picks up the information from our cylinder as far as the outside diameter and the thickness. By default, it makes it match. And it puts in the spherical head. Pick the tool again. Click OK. And there is our vessel. So let's support this vessel. We do have some base supports or saddles. So we'll click the support, we'll pick our vessel, and it orientates to the left edge because I picked closest to that edge. We give it a distance, how far do we want to go? So we'll say 3 feet or 36 inches. We can then go in and pick the type of saddle, putting in the information for it. So the offset distance we'll say is 8 inches. The thickness we'll put in, say 9 inches. Overall length, let's go 7 feet or 84 inches. Overall width, make it 102 inches. And again, our outside diameter matches the existing vessel shell, and we can just click OK. Appears on the top, we can change it, we can rotate it, or we can hit the B for base point. We can get it down to the bottom. Then we can just hit Enter, and the saddle is placed. Rather than repeating the saddle for the opposite side, we can actually just use AutoCAD's copy tool. And we can copy the saddle, and we can copy it over, say, 12 feet. And there's our horizontal vessel. Let's add some nozzles. We'll go to our raised face nozzle tool, select the cylinder, and let's just go, say, 26 inches over. Pick our nozzle type, 4-inch nozzle, taking the defaults, clicking for the location. And we'll take this one coming off the top. Hit Enter, and the nozzle is placed. Let's place another nozzle. Let's say it's going to be our drain nozzle. Pick our vessel. This time we'll come over, say, 7 feet. Put in a 2-inch nozzle. Select OK. And we'll drag straight down, have it coming off the bottom of the vessel, and hit Enter. We'll place one more nozzle, or say the liquid out. We'll pick our vessel. This time I want to reference from the right edge, but I'd actually selected the left edge. There is an option to switch the ends, so we'll just type letter S for switch, and now it references from the other end of the vessel. So if our data was given from that end, we can then use that one. And let's just say we only go 12 inches over. Select our nozzle, 6-inch liquid out, click OK, pick down, and hit Enter. Very easy to do. Let's shade it, spin it around, take a look at it, and there's our horizontal vessel, complete with saddles and nozzles. Let's finish off this horizontal vessel by placing a manway on the back end of the vessel. So we'll just spin it around so we can see the back of the vessel here. Select the manway tool, pick the head. We'll just do a horizontal hinge, regular. Some values come up. For our projection, we'll use 18 inches. For the outside diameter of our manway, we'll use 30. The flange outside diameter, let's use 42. And for the flange thickness, we'll use 2 inch. And we'll say OK. The manway comes in. We can rotate it 90 degrees and hit enter. Let's take a look at it from the top view, the right side view, and finally from our isometric. So now we have completed our vertical vessel and our horizontal vessel, complete with nozzles and attachments. Let's save our drawing. Our next topic is pumps. We'll look at placing a horizontal pump. Under our equipment module, under the vessels tab, there's a compressor pumps and motors tab. We'll select that, and then we can select a pump. For a connection point, we could use an absolute coordinate or just a point in space. I'll pick a direction for the pump, and then we'll just do a horizontal split pump, 3-inch pipe size. A dialog appears. This information would come from our pump vendors, our data sheets. So let's place some values for our pump. Enter the values, click OK, and the pump is placed. We can rotate it, let's say 90, and our pump is placed. The plate showing represents the horizontal split. Let's add the motor. Spin the model around so we can see the back side. And let's add the motor. We'll add electric motor. For the reference point, we'll pick up the end point of our pump. And for the direction, we'll push it back. And we'll do a direct connect with a stand. And the pump motor information appears. And then we can supply some values. Click OK. We can rotate this one to match. And there is our pump. And we can add a base to this, a base plate. And this would just be an AutoCAD rectangle that's been extruded. So I'll just place a quick rectangle. We'll create just a 2-foot, say by 4-foot. We'll use the extrude command, and we'll extrude it, say 1/2 inch for the thickness of the plate. And then we can move the plate onto our pump. And there's our base plate. To make it match, we can use the Match Properties tool from AutoCAD, and we can pick a motor and make the base plate match. So there's our horizontal split pump, complete with a motor and a base plate. Let's add the nozzles. So we'll do an end suction and a top discharge. So back to our vessel parts tab, select the raise face nozzle. As there is no shell head or skirt, use the place option. So we'll select P for place. It then asks for a placement. We'll pick up the center of our pump and select the 3-inch nozzle. Overall length would be our projection. Put in a value of 6 inches and click OK. And there's our nozzle. Let's put a 2-inch nozzle coming off of the top. So end suction, top discharge. Select our nozzle tool, P for place. This time we'll pick up the quadrant using our AutoCAD object maps. And I'll pick up the quadrant of the top of the pump and then drag straight up. This time we'll use our 2-inch nozzle coming off, 6-inch projection, click OK, and there's our 2-inch nozzle. And just move that over 1 inch to get it centered, and there's our pump. The important parts would be the face of flange locations for the top discharge as well as the end suction. Our last topic in Module 2 is miscellaneous equipment. We'll look at creating a compressor and adding an engine. So under our compressors, pumps, and motors tab, let's look at placing just a 2-throw compressor frame. I'll just pick a random point in space. We'll take the default. We'll do a JGK, just a standard frame. We can rotate it. And there's a sample of what the compressor frames would look like. We can also go in and add a cylinder. For the connection point, we'll pick up the end of the line inside of our compressor, drag straight out, and we'll find a matching JGK cylinder. We can rotate it to match. Hit enter to accept. We even have the cylinder unloaders, so I can add one of those. We'll pick up the center of our cylinder, drag off in the direction we'd like to place it, and let's just do a 2-handle matching one. So we'll pick up the JGK HP, and there is our unloader. Use AutoCAD's copy command. I'll just copy it over in 3D space, and we can rotate the components. Let's go to a wireframe just so we can see our connections, and then we can move. And there is our compressor with the cylinders and unloaders. Let's add a motor to the end of the shaft. We can place Caterpillar engines or Waukesha engines. Let's pick a Waukesha. The reference point, we'll pick up the center and we'll drag it off in that direction. And then we can find a comparable motor, pick the VJF. We can rotate it 90, select enter to accept. And there is our 8-cylinder engine, complete with the compressor frame, cylinders, and unloaders. This concludes the topics covered in Module 2, Equipment. Please review Module 2 or select the next module.